Hello everyone, welcome to the video tutorial for exporting results of your analysis conducted within SIFT. This will allow you to know how to report specific signals, metrics, or events from a dataset and to share results from analysis conducted within the application. This tutorial will use the same dataset as the cleaning data tutorial, which is the 4 subjects walking dataset. This is available at the link on the tutorial page on the HasMotion wiki. This consists of overground walking data from 4 subjects. The subjects walked at 3 different speeds: slow, normal, and fast. The data was processed using a pipeline with an automatic event detection and link model-based item calculations. This tutorial also uses query definitions that have been previously saved in a .q3d file. This is also available on the HasMotion wiki page for this tutorial. The file is named ankleangles.q3d. As always, our first step is to load in the library and define the queries relevant to our analysis. We can start with an empty project in SIFT and navigate to the Load Library button on the left toolbar to open the dialog box. We can then click Browse to set the file path to the folder in which the data is stored. As mentioned before, this will be the 4 subjects walking dataset. So we can navigate to this and click on Select Folder. And once this is found, we can then click Load to import the data into the SIFT application. Now that the data has been loaded in, you may choose to explore the file tags, animation, and other characteristics of the dataset within the load page. We can then navigate to the Explore page by clicking on the Explore tab on the left toolbar in order to compute and view our groups. For this tutorial, rather than constructing our own queries, we will be using the pre-built file which was downloaded named ankleangles. If you want to remind yourself how to define queries, you can review the Load and View Data tutorial. To load this file in, you must first click on the Query Builder icon to open the dialog box. Then we can click on Load Query Definitions on the top right side. Navigate to and select the ankleangles file. The updated file on the wiki page will be the Q3D file. However, on this tutorial, this file is saved as a text. So we can navigate to this and click Select. Once opened, they should show up on the queries list as the following: ankle angle X, Y, and Z with the corresponding conditions for the respective left and right signals. Then we can select Calculate All Queries on the bottom of the dialog box, and now close the dialog box. Now that these groups show in the groups list, you may click on any of the groups to show each of the 4 workspaces in the workspaces list below. We can now begin visualizing the groups both individually and collectively in different plots to start our analysis. A full overview on visualizing data is available in the tutorial on the HasMotion wiki page. First, we must make sure that the plot type is set to signal time on the plot control panel here. Then we can navigate to the general options icon on the upper toolbar. Under the plotting options, select 2 graph rows and 2 graph columns to create a 2x2 set of plots in the queried data area. Then we can close this dialog box. Then we can select the top left plot. When selected, a light gray border will appear around the plot. Then we can select the ankle_angle_x group and check off Select All Workspaces. Additionally, we can make sure that the Plot All Traces button is checked off. The plot is visible here now. Moving on, select the top right plot and plot the sequences from the ankle_angle_y group's workspaces. So we can repeat the same process, and now we see the sequences from this group. Now we can select the bottom left plot and plot the sequences from the ankle_angle_z workspaces. So again, we can repeat this process for this direction. Finally, on the bottom right plot, we can select all groups and select all workspaces. We can check off the Plot Group Mean button and deselect Plot All Traces, and then here we can view the group means from each group. SIFT allows you to export the visualizations to one of 4 image formats: JPEG, PDF vector graphic, PNG, or BMP. We can start by right-clicking the bottom right plot showing the group means and select Export Graph from the context menu. This will open the Export Graph dialog, where we can choose our desired export path, where the image will be saved, as well as a name for the file. So we can click on Export Path, and I will be saving it in the For Subjects Walking Data folder with the data set, and naming it group_means, and then hitting save. Now we can leave the Use Current Size checkbox checked and set the format to .pdf vector graphic and hit save. Now this plot has been saved. Alternatively, we can export all 4 graphs collectively by selecting the Export Graphs button on the upper toolbar, here. This will open a similar dialog box where we can again choose our desired export path, which will be the same folder as the previous one. In this case, I will be naming it all_plots and hitting save. Then we can uncheck the Use Current Size checkbox and specify height and width to be 400 pixels each. And now we can leave the format set to .jpeg and click save. For confirmation, we are able to open one of the exported plots here. So we can open the group_means.pdf file. Here we can see that the plot has been exported. SIFT also allows users to export signal data and results from analysis to a text format. We can click the Export Results button on the application toolbar to open the dialog box. In the definition section, we can set the export type to data, the input data to all queried data, and select both workspace mean and workspace standard deviation. In the export results option, we can leave the export format as standard ASCII, and the other format options include transpose ASCII, SPSS ASCII, and a P2D file. We can keep the precision as 4 and click Generate Preview. The table of the results will populate, and you can scroll in both directions to inspect the text that will be exported. For each signal group, we can see in the table that each workspace mean and standard deviation gets its own column, and that there are 101 rows, one for each normalized time point. Note that resizing the dialog prioritizes any additional space for the table to make it easier to view larger output files. So if we were to resize it, we can see that the table expands. Then we can specify a results file name and by clicking Browse, and we can save it in the same folder, and I will be naming this tutorial_export_text and saving it within the For Subjects walking folder. Then we can click Export Results to finalize the export. We can now close the dialog box. In order to export the results from the Principal Component Analysis, or PCA in SIFT, we must first calculate some results and run the PCA. You may refer to the previous tutorial video for an overview on how to perform PCA and interpret some of the results. First, we must make sure that all groups and all workspaces are selected, which they are. Then we can select the Run PCA button in the upper toolbar to open the dialog. We can name it PCA_ankle angles and set the number of PCs to 4 and ensure that Use Workspace Mean is checked. Then we can click Run PCA. A summary of the PCA results will appear in the PCA dialog, and the results of these calculations will automatically populate the PCA graphs on the analysis page. Because the traces for each signal cluster are around a distinctive mean value, almost all of the variance in these groups can be captured by a single principal component. Now that we have performed the PCA, we have results that we are able to export. Again, we can select the Export Results icon on the application toolbar, and this will open this dialog box. In the definition section, set the export type to PCA results, and in the input PCA as the active PCA. Now we can check off group scores, group score standard deviation, and variance explained. In the export results options, we can leave the export format as standard ASCII
and the precision is 4. Now we can click Generate Preview. We can see the table as I expand it, that each signal's group PC score mean and standard deviation is shown for each of the selected principal components, and that the variance explained is shown for all computed principal components. Note here that each row in the export table is now a principal component and not a normalized time point for the other export types. Now we can select Browse in order to save this file, and I will be naming it tutorial _export _PCA and clicking Save. This will be saved as a text file. Now we can click Export Results, and this will be exported successfully. All tools that are available on the Analyze page, such as SPM, curve registration, and dynamic time warping, produce results and graphs that can be exported by the 2 exporting dialogs presented in this tutorial. Various definitions and settings for the exporting options are available for each particular analysis type. If we again select the export results icon on the upper toolbar, we can see on the drop-down menu from the export type that we have these lists of options. So again, as I said, registered curves has a different set of definitions and settings for the exporting, and dynamic time warping and SPM results. So this is all based on what the user wants to export, and this is all available within this feature in SIFT. In this tutorial, you learn how to export the traces visualized in SIFT to common image formats. You also learn how to export different types of data to text, such as signals and PCA results. In addition, you learned that any analysis method can be exported to text files or images. Thank you for watching.